to now move on to looking at how we generate that local climate information that's important for on-the-ground vulnerability and risk assessment, and then thinking about adaptation. Global climate models, the kinds that produce this broad-scale regional information, provide only coarse information. That's sort of averages in temperature and rainfall over broad geographical domains of several hundreds of kilometers. This is because the computations that are needed to run these models at the global scale are huge. So even with supercomputers, we don't have the computational resources to do this with models running at very fine spatial scales. But we still need this information at smaller scales. For instance, we might want to understand what the climate changes are going to be over a river catchment or on a farm or in a suburb of a city. And so what climate scientists do is they use a technique called downscaling to generate this information. At the heart of downscaling is the attempt to translate the very coarse resolution global model data into finer scale information that's usable at the local scale. So to give an example, let's think about trying to understand how hurricanes might change in the future. So the global climate model can provide information on the factors that affect the formation of a hurricane. So how frequently it might form and how intense the hurricane might be. But it can't simulate the actual hurricane itself because hurricanes operate at a scale that's finer than the resolution of the global models. So it won't give us any specific information on how winds in a hurricane might change or how the rainfall intensities in a hurricane might change. And what downscaling does is it tries to fill this gap by taking that large-scale information about the conditions under which hurricanes form and then translating that into detailed information about the nature of individual hurricanes. But it's important to note that even with downscaling, there remain fundamental uncertainties in our ability to provide accurate and precise information on what the climate of the future is going to look like. So it provides greater precision in terms of finer scale resolution, but maybe not accuracy. And one always has to interpret the results from downscaled information, realizing that it's not a prediction. It's what a climate modeler would call a projection, a plausible example of what the local climate might look like in the future. And the important thing to remember is that climate projections don't provide us with the answer of what to do. They're part of the toolkit that we have that help us to understand the nature of risk and vulnerability and therefore start to thinking about the responses that might be needed as part of the adaptation process.